All right, let's get started. Oh, is this on? Okay. Happy to be in 312. Woo. So as you know, I have, you probably know, I have 3 back-to-back 116s right before this, and I was just resetting my mind to do another 116 until I finally realized, oh, this is 312. All right, we get to talk about more advanced stuff. So let's talk about more advanced stuff. We do have to finish the slides from last time. I'm going to back up a little bit and go back to the beginning of Docker Compose. And we'll talk about Docker Compose, and then we're going to jump into live demos. This will be our first of many. I have quite a few of them in this course of just live demos and kind of open-ended, just showing off stuff. Whenever I do these demos, I say this every time, but very rarely does someone take me up on it. So maybe y'all can be the first group that really does. But whenever I'm doing an open demo, when I'm in code and I'm just playing around with things, showing you the things that I want to show you, please ask questions. Like, you can guide the demo. Whatever is giving you trouble on your homework would be, ideally the questions. I'm going to show tips and tricks and everything that I think will help you the most. But sometimes I'm wrong. I don't know exactly what's tripping everybody up. So if there's something that is tripping you up, and you know that's, especially if you know it's tripping up other people, let me know, and I can focus the demo on that. I can steer these demos any which way. I'll always have the full time planned in my head. I'll have enough stuff to fill the time. I'm not worried about that. But I would rather fill it with the stuff you want to see instead of the stuff I think will help you, or that I think you'll want to see. Every grading job fails really quickly. I guess that's optimization. If it always just return false, it's fast. It's optimal performance. All right, so we talked about databases last time, and we need to be able to run that database. Again, we're redoing a couple slides here, but I want to make sure we have the right starting point in the background. So we have to have 2 containers. We're going to run the database in a separate container from our app and run both of those containers. So we could run Docker, build 2 images, and then use Docker to run 2 containers like we saw last Wednesday. But we're going to have a better answer. We're going to use Docker Compose, which is meant to create multiple containers and create a network of containers all in one step. So we just say Docker Compose, do your thing, which will actually be Docker Compose up, and it creates all of the containers we need for our app, which for our purposes will be 2 until we get to homework 4, then it'll be 3 containers to run our single app. And if you're in distributed or you took distributed, you're familiar with this stuff. You can use Docker Compose to create a whole distributed system of containers that will all communicate with each other and do all kinds of really cool stuff with it. We're going to use 1% of the power of Docker Compose in this class. It's very powerful too. So we're going to create this Docker Compose.yaml file, and I talked about formats for a while last time, but YAML, if you haven't seen it, space matters, and this is the syntax for it. Other than that, it's representing things in a similar way as JSON, similar types of data, but just a different format, more human readable. The version of Docker Compose, feel free to bump this up. 3.3 was the cool, the new one when I started using Docker, and I just keep using the same Docker Compose file in all my projects. So if there are new features that aren't in 3.3 that you want to use, just bump up the version number if you want. You won't need any of the new features for this class, but if you want to use them, go for it. And then we're going to have a list of services. So this is like Python, white space matters. So anything indented after this is going to be a service. So Mongo is a service, and this is indented more. So this is all the configuration for the Mongo service. I have an app service, and then this is all the configuration for my app service. So shouldn't be a new concept to anybody here. But that white space matters, similar to code blocks in Python. So we're going to create 2 containers, Mongo and app. Now these are what I am naming them. You can name your containers whatever you want them to be. So there's nothing special about calling this Mongo an app. Typically, your actual app, the front-facing portion of your app that users are going to connect to, we usually just call it app because that makes the most sense. But you can name one of these whatever you want. I just chose Mongo an app. There's nothing inherently special about these names. I say that because, especially because I named my database container Mongo, that does trip some students up. They think that's a special name. It's just what I chose to call it. I think it's a meaningful name because it's a container that runs Mongo, so I called it Mongo. But there's nothing special about it. And those will be the host names of these containers. So Docker Compose will create a network, and that network will have host names Mongo and app, and that's how we connect across these apps. So we no longer connect via localhost. We're going to connect via Mongo and app if we want to communicate across containers. Very important. Mongo, I'm creating just using a container that's available freely out there on the internet. I'm going to download that container, and that's it. I'm not doing anything with it. This is just like having a one-line Docker file from Mongo. Like if you just did from Ubuntu, from Python, it'd be the same exact thing. I don't have any special configuration I want to do with my MongoDB container. I'm just going to grab a Mongo container out there, and that's it. Mongo doesn't force you to set up any password, user accounts, or anything like that. You just start using Mongo, and Mongo by default is going to not allow outside connections outside of your machine. So just trust anybody who has access to your machine, which you better be doing anyway, because they have a billion different ways they can attack you. So we're just going to use the default setup with no Docker file. For our app, we are going to specify the Docker file with the build variable. So we're going to say build dot. This is the same thing as that trailing dot when we said Docker run, and then the -p, the ports, the image name, and then dot, I'm getting ahead of myself there. When we did Docker build, obviously it's the build step. When we did Docker build -t, and then the image name, and then dot, that dot said, this is the directory where you can find the Docker file I want to use. We're going to put our Docker Compose file and our Docker file in the same directory, at least in my example. So I'm going to say build dot, look in this directory for a Docker file. If you want to put your Docker file for whatever reason in a different directory, you would give the path to the directory where you can find the Docker file in the build command, in the build variable. Environment is if you want to set any environment variables. If you do want to use MySQL in this course, and I'll show an example, I think Friday I'll have a MySQL example. This is where you would set your environment variables. If you want MySQL, your environment variables should contain your username and password, or if you're using the root username, at least your password can go in your Docker Compose file. If you put your password in your Docker Compose file, at least in this course, I would not consider that a security issue, assuming that whenever you go to deploy, you would change that password for each environment. So this is where we're setting our environment variables. What we're using an environment variable for is this wait host. We did talk about this last time, but I think this is where I kind of had to stop and rush the end a bit. This is going to wait for the database to be ready before starting our app. This is very important. If you can find another workaround for this, feel free to use whatever you want. If you find something that is confirmed to work and it's cleaner than this, let me know. I'd like to do it. I could update these slides for next semester. But this is the cleanest solution I found that works consistently with any setup that you have, any way you're connecting to a database. This should work with it. Some simpler ways do work in certain situations, but not others. If you have one, I'll take a look and test it, but this one I know is going to work. So we're going to download this script from the internet, this wait command, which is available on GitHub. This is just a GitHub link. You can go there and look at the code. And I'm going to change the permissions to make sure we can execute the wait command. And we're going to run the wait command, and the ampersand says, after this ends and exits, then call this. So we're going to call the wait program, the wait command, and that's going to, as the name implies, wait until the database is ready, and then it just exits. When it exits, then we move on to starting our app. And what this does is allows us to not start our app until we know the database is ready. The wait command is going to read an environment variable called wait hosts, and that's going to specify what it should wait for. It's going to wait for the hostname Mongo port 27017, and specifically what wait does is continuously pings that host and port number with an attempt to create a TCP connection. And as soon as it's able to successfully create a TCP connection on that host, on that port, then it says, okay, I'm good, and then it exits. So by the time that exits, we know that Mongo is accepting TCP connections. So if in our code, the very first thing we do at the top of our file is say, connect to the Mongo database, I know that line isn't going to have an issue because I know the Mongo database is ready to allow TCP connections before my app is started. There's a solution, a semi-solution to this built into Docker and Docker Compose specifically, where it'll wait. I forget what the command is. I forget what it's called, but it depends on. That's what it is. Depends on, and you say my app depends on the Mongo container. But what that does is waits until the container is built and running before it starts. So you can guarantee that the database container exists and is running, but you can't guarantee that it's accepting TCP connections yet. So when your database container is running and exists, the first thing it does is spends a while just spinning up the database. And while it's spinning up the database and getting ready, that's when your app's going to come in with a connection request. Connection denied, and then your app might crash. Sometimes it works. Sometimes, depending on what code, what language, what libraries and everything, there might be a retry. It might retry a couple times and still get in. But it's unreliable. It might not work in all cases. We're making sure that startup script is done and that it's accepting connections before we call our code. So there's a lot of, some nuance going on there with exactly how this works. But to my knowledge, there's nothing built into Docker that will wait for TCP connections and wait for that startup script. There was a proposal. I don't think it's been accepted yet. I believe UFO Scout themselves proposed created a pull request, I believe. But to my knowledge, it hasn't been accepted yet. So UFO Scout, shout out to them. I have no idea who they are, but they have a wonderful solution to this, and I'm glad it exists. So however you can solve that problem is fine. Just make sure it's robust. Make sure it's not a situation, well, it works on my laptop, but when the TA went to submit it, it crashed, couldn't connect to the database. Just make sure you don't have anything like that. Have a robust solution. If you use this solution, I'm telling you, it's robust, and if you have an issue like that and you're using exactly that, the way that I have it set up and no mistakes, that's something I can fix in regrading. Like I can take a look and say, well, you did what I showed you. Like that's not on you. And finally, ports. This is the same as the -P 8080 to 8000. So we have a local port and an internal port to the container, and we're going to map that port. Same exact thing that we were doing with the -P, we just have it somewhere else. So you can see that we have all the stuff that we did last Wednesday when we built the image and ran the container. We're doing all the same stuff, we just have it organized a little different. We still have the -P, we still have the dot for here. We never actually, I guess we kind of do name the image. We have all the same stuff, we just have it organized in a different way. These service names are the host names. I think this is the first slide we definitely didn't get to. These are the host names for your containers. This is very important, especially what's on the slide right now, when you're connecting to your database. However you're connecting to a database, this is connecting to a Mongo database in Python, but however you're connecting to a database, you're going to have to specify the host for that database, or usually if you don't specify any host, it defaults to localhost in most cases. But you're going to have some way to specify the host for the database. It can't be localhost because that's not the host name where the database is running. The host name where the database is running is whatever you named it right here. So whatever string you put right there, you need to put that same string in your code when you connect to the database, because that's the host name where your database lives. Just like saying, MongoDB.com is a host name. This is the host name for your network where you can connect to your Mongo database. If you put Mongo rules #24 or what, I don't know. Whatever you put there, you got to put the same thing here. I don't think hashtag's a valid character, so that's a bad example, but it has to be the same. This can be tricky when, so you can run a local MongoDB and connect to that and use localhost for testing if you like that as a testing setup. But make sure you switch this back to Mongo before you submit, because you need to be running 2 containers when you submit. Using Docker Compose and spinning up a network of containers, that's part of what I want you to get out of this class. So that is a requirement for the homework. Make sure you have that set up when you submit, no matter how you're doing it in your testing environment. And I always recommend, it's in the homework document, but when you submit, I would download that zip file right off of Autolab into a brand new, fresh, clean directory and go through the testing procedure exactly as it shows up in the homework document. There's always a handful of students for every single homework who don't do that, and then they cry after the deadline and say, why did I get so few points? And it's because they, most of the time, it's last-minute panic. They're working right up to the deadline, and at 8:59, they make their last panicked submission, and then they forget at least one setup thing, something like this, and then it's straight fails on all objectives. But hopefully that's less of an issue with the late days, but we'll see how things go. But you have to have this, or else if you don't have that, every objective fails. Like we can't test anything, we can't do anything. We can change this in your code, but at what point are we just finishing the assignment for you? And we say 0. We're not doing any of that. Once you have your Docker Compose .yaml file, Docker Compose up. This is the beautiful thing of Docker Compose. You can put all kinds of configuration in that Docker Compose file. These files can get huge. They can spin up 10, 20 containers. You can have 20 Docker files, one for each one of those containers. You can have a whole lot of complexity of how to build your project and run it in a network of containers. It's just Docker Compose up after that. You set everything up once, Docker Compose up. And if you want to use it without the dash, if you don't want to install Docker Compose, the latest versions of Docker, you can call Compose right from Docker. It's built into Docker these days. Docker space Compose up. And it builds everything. Everything's created. You can run in detached mode. You don't necessarily have to do this. I'd say I'd recommend not doing that, really, for your homework. But I want to mention it here. By the time you get to your project and you're deploying your project, or in general, just when you're ready to deploy your app to the outside world and invite users and send out your domain name and say, hey, go to my website, you'll run it in detached mode. That will run your containers in the background. Just running your containers, you're going to see all of the standard output from all your containers, which is great for debugging, which is most of what you'll be doing. Once you're done debugging, you'll just submit, and you'll probably not think about it after that. But when you're ready to deploy, you'll run it in detached mode with the -D. And then the containers just run in the background forever. And then your app just lives forever. To rebuild and restart, you run your code, you change your code, you test it, you find some bugs, you change your code, you want to retest it, --build --force recreate. You have to have both of those or else it don't work. Frustrating thing for me, because you used to just be able to do --build, and then mid-semester they pushed an update several semesters ago. They pushed an update where you have to have force recreate on there as well. So any student who updated their Docker mid-semester, all of a sudden their containers weren't rebuilding and just caused all kinds of issues. I recommend never updating anything mid-semester. I don't update anything mid-semester. I don't want to touch anything. If things are working, I want it to stay working. But that's a new update. Now we just live with it. -- force recreate. It's not a big deal now because I can just put it in my slides. But when the update was pushed by the Docker team after this lecture, there wasn't a whole lot I could do. Just had to add a note in a future lecture. And a restart without rebuilding. Restart. We'll use this to make sure your database is persisting, to make sure you are using a database and the like. Okay. Any questions? Yeah.
So if we want to build a Docker file that's not in the same directory?
As a string, it's so if you had a you do like, you just do it like this. Oh, they're supposed to say directory, but whatever path to your directory you want. I might have a quick example actually. Like here, I have a separate Docker file and a directory named nginx. So I just put the path to that directory. How's chat looking? So that's from a TA. I don't want to play off too much of what TA is saying. I'll try to quickly say what I want to say. Is Docker compose? Well, let's just do it. So here's a Docker compose file. It looks just like it did in the slides. I have a Docker file which looks just like it did in the slides. I have some code that looks very similar to what we've done before. Just a very simple Python app that just responds with hello. No matter what somebody sends, it's going to respond with hello every single time with no conditional. The only difference is I'm inserting into a database right here and connecting to a database here. So let's run this with Docker compose. Docker compose up and watch it build. So that one I didn't do on purpose. I set it all up the first time, so Docker's not running. If you ever get that error, Docker's not running. I did it on purpose the very first time, but that one was definitely an accident. It's my most common error with Docker. So Docker's starting. It might take a long time, yeah. It won't take overly long, but there are things that, oh, good. But this is fine too. So these are errors you're going to get while you're debugging, so it's fine that they're happening. So this is port already in use, port already allocated. That means somebody's already using port 8080, and in my Docker compose file, I'm mapping 8080 to 8000. That means I'm asking for port 8080 on localhost, on my laptop, and I'm trying to allocate that to have that redirect to inside of my container. Now, the 8000 inside of my container, I can reuse that within containers all day long. But once we're at my laptop level, not inside a container, I have a pool of ports that have to be shared. So somebody's already using port 8080. So who could the culprit possibly be? Let's take a look, because it's always me. It's always you. That's the answer. Somebody's already using a port. You're using it. So let's see who's using it. Right here, I have an app that's running. So this is Docker Desktop. It shows you all the containers that are running and all about your images and all kinds of useful information. Right here, I see an app running. It's using local port 8080. So let's shut that thing down. And then I should be able to use that port. I don't know why that's even running. It's my web server code for this class. And then we should be able to run. And you can see all the MongoDB output here. That's all the startup script. It actually didn't take that long, but all it takes is a few milliseconds to get the timing off. I can see my app container is checking. Oh, it actually went right away. What happened here? I think it looks like it was already running. Let me do a force recreate just so we can see what I'm trying to show you here. So I'm going to do docker compose up -- build -- force recreate. And that's going to force the container to rebuild. So this takes a while. This is my point. If I change any code, I have to do this. I have to rebuild it. This takes a while, and this is what was mentioned in one thing that was mentioned in chat. This can slow down your debug cycle significantly if you're running Docker Compose all the time. I do recommend not using Docker Compose when you're developing. Try to stick to just running Python, running your app, or whatever language you're using, and testing it that way. There are a few ways to set that up. One is to download and install your database. Have your database running on localhost, and then connect to localhost, just like you weren't using Docker at all. And then once you have all your features built and working the way you want, then switch to your Docker Compose setup, spin it up, test all your features again. Sometimes they'll work, sometimes they won't. Do some last debugging if you have to, and then submit. But that is a long time for your debug cycle, for every time you change any code. So I do recommend setting something up, and we'll talk about that probably throughout the semester. I have different things to say. And then we can go to localhost 8000, and localhost 8080. We just had that whole conversation. I already forgot it. We get hello, and I can see that I get all the standard output from my app. I can see all the standard out in Docker Compose, in the terminal window where I ran Docker Compose. So this is going to help me debug. If you're using Python, do not forget the -u right here. That's a very important couple of characters. Don't forget the -u. That's going to unbuffer your output, so you can see things as soon as they're printed to the screen instead of them being buffered. And I can see all the output that's going on in my app. Let's shut that down. And once it's shut down, I'm going to immediately rerun it. I'm going to not force recreate, just so we're not sitting here watching my Docker all the time. But I'm going to run it in detached mode. This is going to do the same thing, except it gets me my command line back. I don't have to take my whole terminal window just to run that. And it's just running in the background. Once I have my app running, I have two containers running now, and I can see them by using some. Let me get out of here first. We can full screen this, right? Let me get in just a regular terminal. Oops. No, I instinctively hit ls whenever I move into a new directory. It's just muscle memory. So let's get into a fresh terminal here. Now that I have those containers running, they are running on my machine, and I can see. Resize this. We'll get this set up. Maybe we won't get those on one line. Hey, we did. All right. Clear. With Docker PS, that's going to show me, no, they're not on one line again. This is going to show me all the containers that I have running. I have two containers running, one for my database and one for my app itself. And I can also go to Docker Desktop. Did I do that? Oh, I did that in the wrong window. There we go. I can also go to Docker Desktop, and I should see them running right here. I can see my two containers running. And if I click on the container, I can see. Well, I can't see. Oh, I have to click on the thing itself. I can see all the standard out here as well. So even though I'm running in detached mode, I still have access to everything that was printed to the screen through Docker Desktop. If you want to look at everything that was printed while your app is running, but you want to run it in detached mode, you have that option. And sometimes it's helpful to enter into these containers. So this is something, when you start really working with Docker, you'll want to use this a bit more. I want to show it now so I don't forget to show it later, is entering into a container. For that, docker-it, I copied the container ID here. I want to get into my app. So I'm going to look at which one is my app. It's this one. And then the command that you want to run inside the container, I want to run my command line. So I'm going to do bash. And what this did, I forgot my exec. Docker exec-it ID, container ID, and then the command. So this is going to bounce into my container. So now I have a command line. It looks the same as it did before, but now I'm inside that container. And we can see a few things. One, if I check the directory that we're currently in, we better be in /root, because I have those 2 lines in my Docker file that set the home directory to root, that set the working directory to root. I like everything just being in root, and then I know where everything is, and I know where I'm going to be when I bounce into the container. So I'm in a directory root. If I hit ls, I can see all of my project code in here. I can see everything that I have for my project. Here's all my Python code. It's all sitting here inside the container because I did that copy ... That got all of the code in this directory into the root directory of my, the directory named root in my container. So I can poke around and look around in my container. This is helpful when you get to, oh, that's so far down the road, but when we get to homework 2, when you're saving images that were uploaded, this can be helpful to bounce into your container and check if those images are being stored properly, if you're having to debug something about that. Where this gets more useful is when we bounce into our database. So one tough thing is trying to see what's in your database. Some students, and myself sometimes, will like to have a path in our web server where you access that path and it does a select star or a find all and just returns everything just so I can see what's in the database. That's one solution, but we have this problem where it's hard to see what's in your database. So we can bounce into the database container. For this, we're just taking the default setup. We're actually at the root path. We're at a root Ubuntu, and we can see all the Ubuntu stuff. And the only thing that should be running here is, can we see it with top? Is the Mongo daemon. So we have Mongo running. We have my bash. That's my terminal that I'm running when I got in here. And then top, the command I just typed to be able to see this stuff. So when I'm not in this container, the only thing that's running is MongoDB. It's an entire Ubuntu instance that's just running MongoDB, or the Mongo daemon program, more specifically, which means we should be able to bounce into Mongo. So if we run Mongo, that's going to give us a command line shell, or the CLI, that's going to listen for Mongo commands. A couple of these show databases. Let me jump over to my code to show you what's going on with this one. Where's my code? So I'm connecting using the host name that matches what's in my Docker Compose file. I'm connecting to a database called CSE 312, and then I'm connecting to a collection named logs. And then in my log collection, I'm inserting a client with the client ID, which is their host and port, whenever a client connects. So I should expect, and I went to the browser one time, so I should expect to see in my database one host port pair when I connect to this. So let's go back to our database. We have our database, CSE 312, and 3 databases that are created by MongoDB. I'm going to use CSE 312. So now I'm switching to that database, and I can do show collections to see all my collections. I only have one, just logs. And if I do db.logs.find everything, I can see, a second one that must have been for the favicon.ico. But I got 2 connections. I got 2 entries in here. And I can see that I am actually storing values in my database. So I can bounce in here and see what's in my database and poke around. I can do find, I can filter these things and do whatever you want. I can even insert data if I get corrupted data. Sometimes it's always very scary, but you can go into the database like this and delete records that were uploaded by accident. But you can access, full low-level control over your database. So that can be helpful when you get to application objectives 2 and 3, when you're working with your database, or all of the other homeworks for the rest of the semester. When you're working with your database, it can help to go in there and take a look at your database. That might be a little overwhelming, so I want to show a different way as well. What's a daemon? A daemon is a program made to run in the background. So it just runs forever and is running MongoDB in our case. Is there a reason to not reuse address? Oh, that's a whole conversation that I missed. So there is another way. In our app, we're mapping local port 8080 to port 8000 to make port 8000 inside our container available at localhost port 8080. We can do the same thing for our Mongo container. Okay, auto formatting here. I don't think so. And get 27017. 27017, and map the container's port 27017, MongoDB's default port. I'm just using the default image, so it's the default port, and map that to my localhost 27017, which will allow me to access the container from outside of the container. I'll rerun this. How long ago was that? Where's my... There it is. So let's rebuild. We changed anything, so it will take a while to rebuild. Go to our browser. Let's refresh a few times. Look at that performance. Yeah. Things perform well when they don't do anything. And now I can access my database from localhost. And some of you, if you were watching, you saw me install this literally right before lecture. But there's software that helps you visualize, not visualize, but see all of the contents of a MongoDB container. I have this installed on my other laptop. It's just something I haven't done on this one before, by the way. But it'll let you take a look at the container. By default, localhost 27017, I'm using all the default stuff. And it says, give me the URI for your database, and I'll connect to it. So let's connect to this and just hope that everything goes, oh, yeah, it went well. And I can see all my databases here. I can click on CSE 312 logs, and I can see everything that's in this collection. I can delete things. I can edit things. I can add new things. It gives us a nice visual, a nice program to be able to work with it. So if you prefer this over the command line, which probably most of you. I kind of like command line, but I don't know. I think I'm just stuck in my ways on that one. But you can use this. Make sure you map 27017. If you don't have this mapping, you won't be able to access your container. This container can't be accessed from the outside world for security reasons, so we got to map that port. Map that port and say, I want this to be accessible to localhost at least. And then we can connect using MongoDB Compass. I didn't even say the name of the software. MongoDB Compass, which is going to let you see all of your data and interact with it. Can very much so help well debugging things during your homework. There's also an option. Should I pile on another one? I just want to get everything out there. This is a live demo day, so I want to just say all the things. Run your Mongo service like this, and then run your app with just Python and connect to localhost. What this avoids is having to install MongoDB. If you don't want to go through the whole installation process and have that running on your machine, use Docker just to run your database, and then connect to your Docker container through your app when your app isn't running in a Docker container. You have that option as well. So there's a mix and matching that you can do once you know how to use these Docker containers. Yeah?
You basically keep that data.
Yes. Yeah, so if you're going to take this last approach that I said, what I'd actually recommend is running Docker Compose, running Mongo, the container, without Docker Compose. So just turn this into what we did last Wednesday. Just do Docker build, Docker run instead of Docker Compose. And then just have that container running, hit it with a -D, have it running in the background forever. And then it can just store your data forever. I tried installing MongoDB on my laptop one time, and I couldn't do it because it kept saying port already in use. Because I did something like that a long time ago and forgot about it. I just had a database running forever. The last thing I want to talk about for this example is PyMongo. What the library I was using to connect to the Mongo database was an external dependency. So I put it in my requirements.txt, and then in my Docker file, I'm installing everything in my requirements.txt. You can install things however you want. Some students like to do just pip install PyMongo right here in their Docker file, and then just add lines for all their dependencies here. I prefer the requirements.txt. I don't care what you do, just do something that's right. I mentioned this before, bless you. I mentioned this before, but a common error students have is they just take my Docker setup, but never create a requirements.txt file, and then they say, why am I erroring on this line? And I say, well, that's installing a file called all the dependencies in a file called requirements.txt. Do you have a file called requirements.txt? And they gave me a blank stare because, they just copied my code and didn't think about it. So I don't care what you do, but do something, and make sure you do it the right way. And if you have that error in office hours, that's not a big deal. I mean, sometimes, if you're confused on what's going on, you have that question and you come to office hours with it, you came to the right place. But that is a common office hours thing, and that'll be my answer. Hopefully I answer it right now, and then there'll be fewer of you with that issue in office hours. But requirements.txt, that file has to exist. I have it right here with PyMongo in there. All right, that's a lot of Docker stuff. Any questions on any of that? There's at least one other thing I want to show. Yeah. You have to, for the homework, you have to run MongoDB or MySQL, whatever database, or Postgres, whatever database you want to use, in your Docker Compose file. So you have to run it in your Docker Compose file and spin up a container that runs it. You don't have to download and install the software on your machine if you don't want to, but it can help your debug process if that's the setup you want to use. But you do have to have it set up with Docker Compose. What is the from PyMongo import? So that's importing this code. So from PyMongo, get the Mongo client, and that's how I'm connecting to my database. This is a dependency. This is stuff, I always have mixed feelings on this. Like, this is a 300-level computer science course. You need to understand external dependencies. But I'll talk about it briefly. This is saying install this. This installs PyMongo. And then this is importing it into my code. Like, I talked about this last week in 1.16. Y'all gotta be on the ball with this one. And then I start using that external library in my code. All right, any other Docker questions? But at the same time, I'm here to teach you how to do this stuff. I'm going to answer the question. But that one always gets me when I get questions like that. Not to something. Like if y'all have questions about when I went into the command line and did all that bouncing into containers and stuff, that's where I expect the questions to be, because that's probably pretty new. You did some of that in 220 and maybe in a few other classes, but that's new stuff. We do this in 115 even. They show you how to do a requirements.txt. All right. So I hope that's just a one-off question. If a lot of you have that question, I'll spend more time on it. So there's something I want to show, a couple things. Just very briefly, we talked about character encodings. There are no other Docker questions, right? This is a Docker lecture, but kind of ran out of stuff to, not run out of stuff to say, but I did want to get to this. I'm assuming that you're overwhelmed with Docker stuff, by the way. So let's run some code on this. I have this method function, I guess, show encodings, and I gave it different strings. And show encodings is going to do a few different things. It's going to print this string in various ways. So I'm going to encode it with UTF-8. I'm going to print the encoded string. I'm going to convert it to decimal and print out the decimal values, which will be roughly the ASCII values. I'm going to print out in hex. I'm going to print out in binary. I'm going to print the length of the string, and I'm going to print the length of the number of bytes in the string. And let's just run this because it's more. Oh, I got rid of my terminal. Oh shit! How do I always forget how to get that back. Terminal. So let's end these containers. I'm going to hard kill them. Examples, encodings. Python 3 character. So for our first string, hello. In bytes, it's hello. In decimal, these are the ASCII values. These are the ASCII values in hex. These are the ASCII values in binary. I have a string of length 5, and it's 5 bytes. Okay, let's get to the interesting one because we don't have too much time. The interesting ones. Now I have the symbol 1/4. When I convert this to bytes, when I convert it to bytes, Python's going to do its best to show it in a human-readable format. With hello, they were all ASCII characters. They were ASCII bytes, so it rendered them as the ASCII values instead of the bytes. It can't do this here, so we actually get the hex values, C2BC, which is how this is encoded in UTF-8. These are the decimal values for the 2 bytes of this character. We get the 2 bytes, C2BC, the same ones that we see here. And here's C2BC as binary. And the length of the string is 1, but of course it's 2 bytes. So this is a UTF-8 character that takes 2 bytes and not a single byte. This is where we can start getting issues with our content lengths. We have a 2-byte and then a 3-byte character with a space in between. The space is valid ASCII, so it's rendered as just a space when it's displayed to us humans. But it's really just these bytes, these bits. We have a length 3 string that takes